Welcome to the Haes Technologies online training video for the single zone AOV panel. In this video, we'll be looking at the product overview, connectivity details, control and indications, and programming features of the panel. The model number for this panel is the SZAOV. It consists of a single zone, a 3 amp integral power supply unit, zone terminals that can be set as conventional or as a twin wire circuit, so you can put your sounders on the zones. That's false alarm management mode, vent status indications and controls, a fireman's control switch input, and also a manual control input there for different types of control switches, PIR and rain sensor inputs requiring an additional plug-in PCB, BMS and vent control inputs using your 0 to 10 volt inputs from control equipment, again using the same additional plug-in PCB, two auxiliary relays, one fire and one fault, a 1 amp 28 volt maintained output suitable for magnetically held back windows, room for two 7 amp hour batteries, and disable and test mode functions. The panel's overall dimensions are 317 wide, 82 millimeters deep, and 310 millimeters high. The back box is obviously slightly smaller than the door on the front there. Details can be found on our manual. Connectivity details. Here we are looking at a picture of the main PCB inside the panel. Starting along the top edge there, up the left hand end, we've got our power supply input that will be pre-wired to the power supply unit inside. Moving to the right, we have our detector pos and neg. This is the circuit can be set as twin wire if you require it, so you can put sounders on the same line as your detection. We then have our open and close inputs, obviously for opening and closing manually. This is useful connecting to other panels. We then have a manual and a fireman switch input, both marked common, close and open. Obviously, activation between a common and close will close. Activation between common and open will open on both those switches. We then have our ACT or motor connections, pos and neg. Our auxiliary pos and neg outputs alongside that, that's 28 volts maintained at 1 amp. And two relays to the right hand end, one fire and one fault, clean contacts, usable for many purposes. Going to the bottom edge, we have our battery input, pos and neg, our sensor input, pos and neg, temperature control. And to the right hand at the bottom there, there's a row of dual switches that we'll run through in more detail where you can make some quick changes to the operation of the panel. This is a picture of the plug-in card that gives us our PIR, rain sensor and BMS inputs. For this single zone panel, we'll be just using the top row of connectors, which is the PIR1 pos and neg inputs for your PIR. You've then got your BMS inputs for your 0 to 10 volt inputs from your BMS system, your rain pos and neg terminals for your rain sensor, and at the bottom there, the 12 volt pos and neg terminals will be fitted so that you can supply the PIR. The PIR2 and BMS2 inputs will not be fitted for this panel. For mains input connectivity, the AC mains wiring should be routed as far as possible to the upper left-hand side of the enclosure, so you're not running the mains cable all around the panel. The little PSU itself is equipped with a 4 amp internal fuse. It's non-changeable, it is electronic, so there's no reason for that to blow. The PSU itself is rated at 230 volts plus 10%, minus 10% tolerance at 50 Hertz, and it's rated at 3 amps continuous. The panel takes two standard 7 amp hour batteries. We recommend the USA range. And there's also the 28 volt 1 amp maintained output there suitable for magnetic control. Batteries should be wired in series as per any other panel with 28 volts. The panel comes with the two relays inside, both rated at 30 volts DC at 3 amps. They're voltage free changeover contacts, one fire and one fault relay. The zone circuit or detector circuit can be wired conventionally. It gives you a single zone of detectors. Programming features, you can have things like latching, non-latching, short to fire. You can turn the head removal on or off. And it's all monitored with a standard 6K8 resistor. By flicking the switch, you can convert the zone terminals or detector inputs into a twin wire operation where you can then fit sounders onto the same line as your detectors. It does require SZAOV equipment, and it's still monitored by a 6K8 end of line. Has a electronic overcurrent circuit protection rather than a standard fuse. The fireman switch input consists of a common, an open and a close. The common and open, common and close are monitored by a 6K8 end of line. And to trigger the input, you'll short or apply a 2K7 resistor across common and open or common and close. The manual input is very similar. It consists of exactly the same monitoring with 6K8 end of lines between the common and open, common and close, and again 2K7 between common and open or common and close will activate the inputs. This can also be configured for ventilation mode, so you can fit a thermostat to these inputs to control the opening and closing of the windows via a thermostat control. For the actuator pos and neg connections for your motor or actuator, the maximum output is 2.5 amps continuous. It's a polarity reversal system, so normally there's no voltage or a small monitoring voltage on those terminals. When you open, they become pos and negative 28 volts. When you close, the voltage polarity reverses to close your motor. It's a maximum inrush of 20 amps for 2 seconds. And your circuit there is open circuit monitoring of 10K. So anything above 10K on that input will show up as an open circuit. Anything lower than 10 ohms will appear as a short circuit on the actuator input. Most motors will be in the middle there, so most motors will act as the end of line, so you won't require an end of line. But if you have a motor that's higher than 10K, it's still usable. You fit a standard 6K8 monitoring resistor on the motor itself. It's fairly rare. Most motors will monitor quite accurately. For PIR detectors, there's standard PIRs for trap risk detection mounted near the window. The 12-volt supply comes from the little expander PCB card that you plug in, and the end of line monitoring is 6K8. The rain sensor override feature, obviously in a non-alarm condition, the rain sensor input will close the windows if it rains, unless the system is an alarm, which will override. Again, it's a 2K7 trigger value and an end of line resistor of 6K8. Controls and indications. So the panel controls can be enabled by the key switch on the front or by entering a 4-digit code. The default is 1234, but this can be changed by the engineer. The controls you have on the front, you have a open vent control, which is in red. This is used to open the vents, obviously. You have then a close vent button, which is blue, used to close the vents. Have a green reset button, resets the panel back to standby mode after an activation. Then below those you have button 1, also marked as disable mode, used to disable circuits or vent outputs. Button 2 is designated as test mode, used to put circuits into test mode for your weekly servicing or your annual servicing. Button 3 is your mute buzzer. This mutes the panel internal fault and alarm buzzer. Button 4, test lamps and buzzer, used to illuminate all LEDs and test the buzzer when you push that one. And then the enter button just to confirm any codes you've entered. Each of the buttons 1, 2, 3 and 4 have a dual usage because they're also used to enter different codes for different programming features. At the bottom there, note some buttons have other functions within the engineering options beyond their normal functions on the front there. LED indications on the front. You've got a vent open LED. When this is lit permanently, it means the vent is in the open position. When it pulses, it means the vent is opening or travelling. Same for the vent closed LED. When the LED is on, it means the vent is in the closed position. If it's pulsing, it means the vent is closing or travelling to that position. If you have vent open or closed plus the PIR LED pulsing, it indicates that the vent has been stopped by a PIR activating as a trap risk indicator. This can only be cleared by pushing reset on the panel. You then have an input LED, again referring to the input circuit inside the panel. If the LED is pulsing, it indicates that the input circuit is faulty or disabled. Same for the detector circuit or the zone circuit. If the LED is on, detector circuit is open circuit. If the LED pulses, the detector has been removed. The supply healthy LED, while it's on, it means power on, mains or battery supply. You then have your general alarm LED pulsing, indicates the input circuit or detector circuit is active. Continuing with the LEDs, general fault LED. If the LED pulses, indicates one or more faults are present on the system. Again, if the general disablement LED is on, it means you've got disablement set. If the LED pulses, it means you're in selection mode within the disablement selector. Test mode, similarly, if the LED is on, it means you're in the test mode or test mode is active. the rain status LED comes on, it means the rain input is active. If it starts to pulse, it means the rain input is faulty or disabled. Similarly with the PIR status, if the LED is on, it means the PIR is active. If the PIR LED pulses, it means the PIR input is faulty or disabled. Power supply LED, or sorry, the power supply supply fault LED. If it's pulsing, it means you've got a mains or a battery failure. The system fault LED, LED on means the panel is non-functional or is literally useless really. If the system fault LED is pulsing, it means it's recovered from a serious system fault. It's just to let you know. And then lastly, you've got the access level LED. If the LED is on, it means the controls are active. If the LED is pulsing, it means you're set in engineering mode or the engineering mode deal switch has been in the on position. Programming features. So inside on the bottom right hand side of the main board there's a row of 7 little deal switches. Switch number 1, when it's set in the on position, is the actuator invert. In the on position, the output logic is inverted, so the actuator will do the opposite of what you expect. Switch number 2 is the aux invert. In the off position, or default, the aux voltage is present to drive your magnetic windows. But you can invert that, so you can knock that switch number 2 on, and the aux voltage will be off and will go on in activation, so it works the other way around. Switch 3 is the actuator power. In the off position, normal operation, in other words, normally there's no power, and then it operates when you get the open, the voltage is applied as a positive voltage. When it closes, the voltage spins. If you turn switch number 3 on there, it changes the way it works, so you end up with a permanent output on the output, and then when you open or close, it turns off the outputs. Switch number 4 is your twin wire mode. Sets the zone as twin wire operation for your detection zones. It allows you to fit the sounders on the same line as your detection stuff. Bear in mind you must fit SZAOV compatible equipment. Switch number 5 is not used. Switch number 6 sets the panel into program mode, waiting for you then to enter a code for programming. And switch number 7 activates the BMS mode. This requires a little additional card and allows you then to input a 0 to 10 volt input from BMS equipment to proportionally control the opening of the windows. So the programming features for this panel, you've got the motor opening and close times that you can set individually. You've got the disable actuator short circuit monitoring. This is useful if you've got a motor that falls below the 10 ohms. I have to be slightly careful here, so it will allow the use of the older motors, but they must still be within the current range of the panel, and they must be no lower than 1 ohm short, otherwise it will damage the panel output. You can disable the battery monitoring if you want to run this panel from some external charger. You can disable the mute tone, so by standard, if you have a fault and you hit the mute, the panel will beep every 8 seconds. With this programming function, you can turn it off so when the system's muted, it stays muted until a new alarm comes in. You can change the access code for your customer. Default is 1234. You can then also zone and input programming. So for any zone or any input, you can make it latching, non-latching, short equals fire, and for the zone itself, you can disable the detect removal for monitoring. You then have false alarm management options where you can set false alarm management type A non-displayed to the zone and input terminals. You have a thermostat input mode that uses the aux in. This allows you then to use a thermostat to control proportionally the amount the window opens. You then have a dependency mode A mode for false alarm management, which you can apply to the zone. Disable functions for vents, the opening inputs, close inputs, detector circuits, rain and PIR functions. They can all be disabled individually. And then you have your test mode function for your servicing. All these programming features can be accessed by turning on the programming switch inside on the deal switch number 6, and then using the code supplied in the manual, you can set or change any of these functions. That's the end of this session.